The next assumption we're going to relax is the assumption that the cost of the item is independent of the order quantity. So we are assuming that if we order more, we're going to have a discount. So because of that, we have to now add the cost of the item to the total cost. This is dependent upon EOQ. So once you do that, okay, so this is your annual ordering cost, this is our annual holding cost, this is our annual material cost. So when you add that, and if the prices differ for different quantity ranges, then you no longer have a single cost curve. Okay. Now the cost curve becomes disjointed based on when we have discounts. So for example, here if you order up to 999, you have no discount, like say $5 is the cost. But if you order 1000 and up to 1999, you get a 4% discount. So that means your cost is going to be $4.80. 2000 and over, you get 5% discount. So your cost is $4.75. So that's what happens here. From 0 to 1000, you have a cost curve like that. And then 1000 to 2000, your cost curve is like this. But that's infeasible. Okay, that's the minimum cost, but you can't order less than 1000 and qualify for this. So this cost curve is valid only in this range. And a similar thing happens after 2000. So because of this discontinuity in the cost curve, we cannot derive a single formula for handling this particular situation. So we have to come up with what is called a quantity discount algorithm. So you have to do this step by step. Your textbook does it in one way, but I think a more straightforward way is what I'm going to present, at least what I think is straightforward. So let's head on over to Excel. Okay, so this is the example that we are working on. All right, so up to $9.99, $5, and then $4.80 for 1000 to 1999, and then $4.75 for orders 2000 and over, and then ordering cost is $49, annual demand is 5000, and the inventory carrying cost is given as a percentage, 20%. Okay, so let's assemble all that in Excel. Okay, so annual demand rate is 5000, ordering cost is $49, and holding cost is 20%. Okay, let's make that into a dollar. Okay, and let's set up the quantity range. So let's do this. Okay, okay, so we'll enter the minimum quantity for the range. So minimum is 0, then our unit cost is going to be $5, right? But once you hit 1000, if the minimum quantity is 1000, then the cost will be $4.80. Once you hit 2000 and more, then the cost is $4.75. Okay. So the first step, what we have to do is to simply use the formula EOQ formula and see whether the quantity that we get is feasible or not. So remember the cost curve being like this, where the minimum occurs in an infeasible quantity range. Okay, so that's what we have to test first. first let's figure out what the holding cost will be. The holding cost will be unit cost times the percentage. So make that absolute reference, so we can then copy that across. So now we have the holding cost, right? So let's put some borders like that. So let's just go ahead and find square root of 2 times demand, okay, that should be absolute referenced, times C sub O, that also must be absolute, divided by C sub H, okay, and that should be relative. Okay, so now, okay, now you see this quantity that the formula gives is less than 1000. So if you order that quantity, you will not be able to order it at the price of $4.80. And the same case here as well. So what we need to do is to check and see whether the quantity that we have meets the minimum for the range. So if you say if that quantity is greater than or equal to that minimum, okay, then we can order at that rate. All right. Okay. Otherwise, we have to order the minimum to be able to qualify for that price. Okay. So then the candidate for that range is 1000 for that price, 2000 for that price. Okay. Now what happens if this quantity that you calculate is greater than the minimum of the next range, right? So suppose if this turns out to be 1200, right? So 1200 means you can qualify for $4.80. You don't have to order at $5. So then you can ignore that Q from the formula. So the rule is, so here is how you should look at the rule for determining what the candidate order quantity value will be for each range. So first let's look at the ranges here. So range 1 is actually, it's actually from 1 to 999, right? Range 2 is 1000 to 1999. Range 3 is 2000 and above. So each range has a lower limit and an upper limit. So let's call this LL is lower limit, okay, and UL is upper limit. Yeah. So when you find the Q from a formula, now you have to compare that Q with these two lower and the upper limit numbers. Okay, like if it is for the first range, you compare the Q that you get with these two numbers. If it is for range 2, the lower limit will be 1000, upper limit will be 1999. Okay. If it is for range 3, the lower limit is 2000 and there is no upper limit. Right? For the first one, the lower limit is 1, upper limit is 999. For the second, lower limit is 1000, upper limit is 1999. For the third, lower limit is 2000, no upper limit. Okay. So then the rule that you need to apply is you look at, okay, let's so Q is equal to Q from formula. Okay, so like the formula that you used here to find the Q. Okay. The rule is if Q is less than lower limit, then candidate is equal to the lower limit. Okay. Now, of course, for the first one, you're not going to have an EOQ that's less than 1, so it will always be greater than that. Okay. For the second one, it could be less than 1000, so then you get to 1000. So that's one case. Q could be less than the lower limit. The second case is if Q is greater than or equal to lower limit and less than the upper limit, or less than or equal to the upper limit. Then candidate is, so that means the Q from formula is valid for that price. So candidate is equal to Q from formula, is equal to Q itself. Okay, Q is Q from formula, right? So if Q is between the lower and the upper limit, then you leave it as it is. Okay. And if Q is greater than the upper limit, so that means your Q is now worth the discount. So you don't have to the higher discount. So if Q is, so for example, if this formula turns out to be 1200, then why would you order at $5? You would go here and order because your formula gives you 1200, which qualifies you for $4.80. So in that case, you don't have to worry about that candidate at all. You can just ignore that candidate. So if Q is greater than the upper limit, then ignore the Q. So that is the rule that you should follow. So here, of course, the last case did not occur. For the first one, it was like that. So we kept it like that. For the second one, it was like that. Q that we got was less than the lower limit, so we upped it to the lower limit. The third also the same. It was lower than the lower limit, so we upped it to the lower limit. So now these are the three candidates. Now what we have to do is to compute the cost for each of these candidates and then compare.